Good afternoon, students. How are you?
Good afternoon, sir. How you doing?
Aye, aye, aye. Taking an easy one rough. Easy one rough. Um, I've been begging for 2 more minutes here. Hang on, I'm here. Just give me a few minutes, please. In the meantime, for those of you who have not yet completed your assignment, the 5 questions, you can start looking at them. But give me a few. I'll be back very shortly, please. All right, guys. Let me apologize for the delay. If I were to confess with you, my headspace is really all over the place. I just used a little time a while ago to kind of just compose myself to get the ball going. I profusely apologize. This will not affect us completing the syllabus in any way, shape, or form. But I had to just compose myself a little bit before we start. Now, how are you guys doing?
Good, except for the news.
Yeah, so you can understand why how I'm feeling, huh?
Yes, sir.
Yeah, man, trust me. To be honest with you, if I were to confess, I said I was going to call off the class, and I said no. I'm not going to call the class off. I'm going to still come. I was actually in a meeting when it happened, and you know, of course, the meeting ended almost abruptly, and it just gosh. Anyhow, I don't know why people have to be that callous and evil and wicked, but let us go on. There's another apology that I need to make to you guys, and I'm not too big to apologize. So I was in the process of sending out the grades. Sorry, not the grades. The marked papers, and then I saw my supervisor sent an email that only those persons who are registered should be given grades, and I was like, oops, that is a little bit late because I already posted my grades to Edico. So I am to only send the marked papers to those who are registered. And the truth is, I didn't even have the time today when I was supposed to do it after my meeting. You know what happened, just kind of mess up the rest of my day. I did absolutely nothing thereafter. All right. So I was unable to just double check, and I don't want to just wholesale send the stuff off. So forgive me. Fret not, the papers have been marked. There are 1, 2, 3, 4, 5 of you that I need to post your grades to edit for. I will post the grades. No, I refrain from posting the grades because of the rest of the grades, that is, because of the message that the vice principal sent out. Whenever I think I had copied something to you or said something to you in the group. But just give me a few more. I'm going to kind of after class tonight, sleep off this feeling, and then hopefully get up, and then I can just hit the ball running in the earlier clocks. But outside of that, though, I really trust and hope you guys have been working. I don't want, not because the mid-semester would have passed and you feel comfortable with what it is that you've got, or that, well, at least we pass it. I don't want that attitude. The attitude that I want is when I send the papers, you're going to say, sir, I missed 1 mark or I missed 2 marks. I have seen where I've missed those marks. So it is that you can learn from your errors. And that's the aim of me sending those out to you. So again, please forgive me. It's not that the papers have not been marked. There is evidence based on the grades posted that the papers are marked. It's just that I would have done it today, but you know what happened today, and kind of just threw me off. But nonetheless, I think we need to continue. I would love if I could finish the syllabus on schedule. I mean, like in December. So come January, we just touch upon little areas and so forth and so on. All right. So with that said, I did promise you that I'm going to be moving into integration tonight, but also that I promised you that I'm going to be doing the 5 questions that I gave you in class. I gave you for homework. And I'm now going to be starting. I have not yet done those questions, but I'm going to be starting with the square rooted questions. Let me see a show of hands up. Well, I'm not going to raise it.
That question before you move on.
Go ahead, Papa.
Sure, I kind of feel we don't know how to explain it because I'm anxious to see the mid-semester, like the correction or whatever went wrong. So for
Uh-huh.
me, I kind of feel depressed. It's like I can't move on. And also as well, I want to know like how we know if we're registered or not.
Yeah.
I have like a list of the persons to register because me not gonna lie, media have issues choosing the courses. And me have to send a bag of email. So me not really know if me registered or not.
Also,
So me
so,
have to
chances are you are not registered then.
sir, me not sure.
Sir,
And that's
sir,
why
is it that registered mean you pay the fees?
No,
Or
that's registration don't
select
mean
the
that you pay the
course?
fees. You select the course and you've gone through the process and now working on the payment of the fees. So it's not necessarily paying the fees, but selecting the course. Hold on. And next on, you don't need to be depressed. I mean, leave
So,
that
sir,
to
you're saying
and I
it's not
really
fully
say
registered, they're
depressed
looking
are the
for.
right word, but it's just like me like get over things like me know some of just do the mid semester, me know say me probably have ear as a
Lexton.
Yeah.
Let me just tell you something straight up. I am sure you'd have done some other mid semesters from some other lecturers and you don't get back no grade yet. Talk truth.
Technically, I just two of them me do so far still.
Okay,
And
technically,
one of them was
And one last
yesterday.
night.
and one was yesterday. All right. So when you
Yes,
did
it
my
was you and yesterday on.
okay, so when did you do my mid semester?
From what pick you fill up?
Jesus peace and we
You need the good answer.
you know, I didn't plan to come to class tonight to laugh, you know. So don't let me pop up here because I know you're supposed to know that I love laughter, right? It's
Sir, we
soothing to
need
the
to look
soul.
after right now. So
I'm if I tell you, trust me. I'm if I tell you, trust me, that's for real. Yeah, man. But the point I'm making is your exam was last week this time, Friday, Saturday, Sunday, Monday.
short, sir, you too lie. Feel like a lifetime ago.
No, man, I tell you straight talk, and then no, guess what? You see, for my post those grades, I've had students calling me, sir, are those the final grades? Yes, they are. So I know you guys saw those things long before you come to class. So they think send me the fool. So when you hear me say it at the end of the class, it's just like me never want to say it before.
What? That's
Yeah, man.
crazy.
So when you hear me come on and say, oh, by the way, those grades have been posted, you know, things I'm a big head board, me know see it long time. As a matter of fact, one of my so-called besties in the class, as I say, okay, class, goodbye, my phone, ring, 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 ring. As like, you can't even wait until me dumping and curry chicken, go down, no, sir, we need to talk to you. You see, leave Kelvita alone, you know. All right, but yeah, man. So I'm just trying to check a system to see if I can just say something to you wholesale, but the system is then next time, let me ask you a question, Papa. Then suppose me never did mark the paper.
Sir, Kelvita not
Sir,
gonna
me
make
would have depressed times
just
too.
remember.
Yeah.
Sir, honestly, between me and you, sir, you see, because I know my strong suit.
Uh-huh. But I know you saw your grade, Lexon. I know you saw your grade.
Sir, but you don't know, sir, when you just want, you know,
All right, let me
carry it, sir.
all right. Hold on.
Good evening, sir.
1 minute, please. sorry. I'm here talking and I'm muted. I was trying to disconnect the audio from one other device. So I was having an echo. That's why I was whispering. Let me just check the system to see if I can. This is maybe class list. I don't want Lexon to go through class and don't learn nothing tonight. So let me just double check on this. This is what now. Undergraduate even in campus. Not this one. Oh my goodness, there are several of the students in the class that are unregistered. Now I won't read out those. I'm just going to count those that are registered. 1, 2, 3, 4. Only 4. All right, hold on. Let me just.
Where's the sermon registered?
Sir,
Can you
I'm
chip
not,
out
you
a
know,
while
you
ago,
can
you know?
call out mine in a sir, I'm registered.
1, 2, 3, 4. I'm only seeing on Arion. I'm only seeing 4 students that are registered. Only 4 students that I'm seeing registered.
But sir,
Sir, when you say
area
register, what
not
do you
go
mean?
show registered only when you're fully registered.
No.
So if you get the emails, is right, the Zoom email, that means you register.
All right. Guess what? I want to be compliant. I really want to be compliant. I don't want nobody have to write no, and call up my name, say I never did what I was supposed to do. So, as I said before, I was supposed to check this today so it is that you could get this stuff. But because of what happened today, I did just lock off. So I never did it. Now that I'm looking at the list on Arion, I'm only seeing 1, 2, 3, 4, and I'm seeing the 4 students that are registered. The others, I'm seeing the status unregistered beside the name. I don't know what it is, so I will send Mrs. Campbell a message in class. No.
Sir, I am like 99% sure it's because the school fee didn't not pay. Or at
No,
least in
man.
full.
Me not think of that.
It's
No,
not
Alright,
every
sir.
year the
Alright,
same
sir.
thing, sir.
Sir,
You only consider you registered when you pay.
fully paid, yeah.
Oh, that is the
Sir.
situation? Yes, Papa.
Sir, how is it that we can go on air on ourselves to check to see if we're registered?
Well, log into your Arion and click on
Right?
bottom left-hand corner where it says, I think it has something about status or registration. You can look at it.
It going to not registered once you not pay your fees.
So we
I'm
have
telling you,
registered.
sir. Telling you.
Bottom left.
Just tell the 4 person register and we can know.
No, I can't do that. No, I can't do that.
All right.
Because
Alright,
if
See my name,
if
sir? Come on, it's my name.
no,
Register.
your name is there. I won't tell you though. I mean, off the air I can read, but I won't read. Confidentiality is yeah. I agree with you that we need to. Confidentiality is important, and I'm going to do that. But I think
mine still.
I think we need to. I think we need to move. I think we need to move. So what I'll do, as I said before, I really want to be compliant. I don't want to break the rules, because it was sent out, and I already issued some of the grades before, but I issued the grades before the email came out. I really want to be compliant. So let me speak with Mrs. Campbell or get some clarification on the matter, and then I'll be more than happy to release it. As I said before, your papers are marked. I have the stuff here that I can send out, but I really just want to be compliant. But nonetheless, shall we move on? Don't be depressed. You'll be fine. You'll be more than fine. I promise you, you'll be fine.
See, mention not registered.
Where should we check to find out, sir?
Somebody
If
just
you're
posted a while ago.
registered, go on Arian and look where it says registration.
Right.
To the column to the left, click on it and you'll see check registration status.
Mm-hmm.
And then select the term. Fall semester, semester 1, undergrad evening. Here.
All right, thanks.
You're welcome.
I really hope you understand my position, though. I'm between a rock and a hard place, and I did my part. It's just that then tell me some must hold on. So I just have to hold on. You guys are fine. Fret not. All right, so let us move to our differentiation. I'm very, you know, 1, 2, 3. This is, oh, that's why I'm so far. Okay, I was about to say that, you know, I have 3 more areas. Well, after I start the new area tonight, I'm going to have 2 areas to complete the syllabus. And I was saying, oh, I'm finishing the syllabus quickly, but I recognize that we're in November. So if we're really doing exam in December, I would be slightly behind. So what I'm feeling comfortable about is that based on the mid-semester, I surmise that most of you in the class are following what is happening. And I just need to I started the conversations already with some students. So I'm going to be working in earnest just to be true to my words and just link with those who are seemingly struggling, and then we can just get it out of the way. Let me share the screen, please. And I don't want anybody to be share the screen to be discouraged. Just hold on. You will get the grades. I mean, not the grades. You'll see the marked papers. Just allow me to do some due diligence. All right. So those are the questions. Did we get an opportunity to work on those questions for me?
Sir, those two.
Attempted it.
Sir, I attempted it, but sir, your question's tricky bad.
Aviana, leave me alone.
Sir, come like
Sir.
you with the easy one in a class and then stop with
Sir, you should have write trouble beside all of them.
You could have just take out the minus 2x plus 1. Just take out that part.
You know, I did say that I came to class tonight drowning myself in my sorrows, and I didn't intend to laugh, and you guys are bringing it out. It is not difficult. It's better I give you these questions, and then, you know, I'm going to
Sir, it is not difficult for you. For you, sir, for you.
Yoni, leave me alone. All right, let's go.
Anybody can see the screen?
You can see the screen, Alexa, no?
No, it's still as a sharing.
Anybody see the screen?
I can see it.
Yes, sir.
I'm seeing it. Let's start with 40 minutes.
Your depression pass through to the computer. Waiting on you, Lexon. Tell me when you see it.
Sir, may I rejoin?
All right, cool. All right, so until he gets back, they
Sir, come up now. You can continue.
all right, great. So normally my students are very nice to me, and I'm speaking about the calculus one in particular. Tonight you seem to be very unnice, to say that my questions were brutal. I forgive you because there's no truth to it, or to the claims. So together we're going to work through them. We're going to work through them together, and then we're going to see what is happening, or what is happening. All right. So my question to you, and I really want this to become very interactive, because as you see that I have not yet done the question, and I want us together work these questions so it is that we can concretize our understanding. I took out my tablet to write, and I said, no, I'm not going to write, because I want them to see what is happening here. Tell me, which method am I going to be employing in order to work this question?
Sir, are you sharing?
Very good. Wow.
Sir, are you sharing screen? Sir, that's the easy part.
I'm sharing screen.
Sir, my internet giving problem here.
Okay. Charlene?
Yes, sir.
Did you just give me a while ago and said exactly?
Yes, sir.
No, I don't think so. No, not I don't think so. I don't think so, no. Kelvita, is Kelvita here tonight?
No, sir, that's what I was saying to you. Kelvita is sick.
Oh no, I wonder if it's too much of a rum. Blame it on Ryan. Ryan. Blame it on Ryan. Blame it on Ryan. All right, come. Kelvito, when you listen to the recording, Honey Bunches, we prayed for you. Yep, boo. You'll be just fine. Using the chain rule. Counting so much coming, Jesus, Lord. Protect me. All right, so the chain rule. So you said that was the easy part. So what is the differentiation of 4x to the 5th?
20x to the 4th.
20x to the 4th is correct.
That's our next easy part.
All right, so 20x to the 4th is correct. Very good. Oopsie, I should write divided by dx. All right, you know what I'm going to do? Let me do it in stages. It's going to be a little longish, but let me do this so that you can see and follow. What was it? No, 4x to the 5th. So I'm going to put that as 4x to the 5th, and then I'm going to
shift the device to the right some more, please.
a device to the right.
The software that you.
Oh, yeah. I could do that. Not a problem. Anything for you, Sashibu. All right.
Sir,
Yes, Papa.
rookie question. Why? So right away, everybody could have spot say you will use the chain rule to solve this problem, right? How do you know that?
Answer the question for me, please, guys. How do you know it's the chain rule? Very good
By
question.
the plus and the minus.
Because it's the signs separate the terms. Yeah.
The 3 terms.
Excellent.
Yeah.
You hear them say all of them right. So what is happening, Ron, is that I have 3 terms. 4x to the 5th is 1 term being separated by this operator. Then I'm going to have the root of 3x squared minus 1 as a second term being separated by the operator. When I put this minus and I said, Jesus, I wanted, matter of fact, I had minus 2. And then I said, no, I bet you some of them going to put the 3x squared minus 1 minus 2x under the parentheses. I said, no, I mean, under the square root sign. So I said, no, I don't want to mix them up. So I just put on something else. So we have 3 terms. One, this term, the 4x to the 5th is being separated from this term by this operator. And these 2 terms are being separated by this operator here. So once you look at it, you know that it's a chain rule. The chain rule are terms that are separated by my addition and subtraction signs. Once I have a multiplication sign in there, it means that it's going to be the product rule because something is being multiplied by something, right? Okay, I could still give you, good question, you know, I could still give you a chain rule, but the chain rule involves some product in there. I still could give you a chain rule, but in the chain rule itself, look at this one for argument's sake. This could be a chain rule because you have 3 terms being separated by my operators. Are you following me?
Yes, sir.
But this term inside here, what would I have to use in order to solve it, to work it out?
Product rule?
The product rule, right. And then in this one here, and oh Lord, come on. I know I did one of those based on the question that was asked. This one here, this one again can be considered a chain rule because I have 1, 2, 3, 4 terms on the left-hand side. All right. But this one here is going to be which rule?
Quotient.
Quotient. And this one is the?
Product.
And this one is the?
Product.
Very good. So the point, the question that you ask is one that is very important, but it is going to take a trained eye to see the question to know that product rule, chain rule, quotient rule. Oh, this is a chain rule, you know, but this chain rule now includes the product, the quotient, the power rule, right? Because this here is the chain rule, but this chain rule includes how many power rules?
2.
Very good. Sir. So using the chain rule, which includes 2 power rules. Right? Right? So I have this one here as a power rule and this one here as a power rule. So they can give you, so it can be mixed up. It can, put it this way, it's like a smoothie. You know that you have one smoothie, but in the smoothie you have a kaleidoscope of different fruits. And you have to take a trained taste bud to say, Yes, it contains blueberries, and you may know because of the grits that it contains blueberries, but it may contain some other fruit that, you know, the taste is overpowered by another taste that you can't even tell me that this is inside of it. All right, so let's go. So what it is that I would have done, and forgive me, I'm going to write step by step because I really want you guys to get it. So I'm going to be rearranging. I'm going to rearrange and get this. So tell me if you agree with this rearrangement from the square root sign here to here.
Yes, sir.
Yes, sir.
All right, very good. Now, remember now, you know, I'm hearing the familiar voices. The unfamiliar voices, I need to hear from you. This is the only way sir will know if you are understanding. Even if you say, yes, I want to hear from you. So now that oh Lord, this is not divided by dx, and I can honestly.
Sir, I rearrange the right word or basically convert the square root.
I rearranged it. It's the same thing, but I just rearrange it. It's rearrange is fine, man. Rearrange, convert, change over, fix up. Yeah, the same thing. So I'm rearranging the question. So what I did here was have dy by dx, but it shouldn't be dy by dx because it's just y. Because I'm rearranging it to give me just y. So now I have.
What happened to the let, sir?
I don't have to put let because the function was given as y. So the question gave me y equals. So if it had said to me, find the differentiation of 4x because it never named it as y, I would have to let the function be equals to y.
Well, sir, you have a question that's a y equals square root 2x plus 3, and then you say let y equal.
You know, so nobody knows that matter. The left part.
Yeah, and I didn't have to put. The reason I did this here is that I put it there because I want to show you which one is my first term and which one is my second term. But really and truly, let me just. Did I give you a question like that before? Yeah, man, it's important. It's very important. It's extremely important. Let me see if what do I have? And maybe it's how, and it's because it's how I write the questions. I don't want you to go into the exam and not do the stuff. Remember, you know, irrespective of what is happening, because we're doing online teaching and learning, my students, they still must get the stuff. All right, look at this question here now. When I say differentiate 4x squared plus 3x minus 1, who am I differentiating? Okay, when I differentiate, I'm going to get dy by dx, talk truth. Somebody say yes, no?
Yes. Yes.
Or I can get f dash of x, don't it?
Yes, sir.
Okay.
No, it doesn't belong to anybody.
Thank you very much. It doesn't belong to anybody because there's no y for me to get dy by dx. There is no f for me to get f dash of dx. There is no g for me to get g dash of dx. So it is just there. I don't know. This has no name, so I have to first name it. So when the question is given without the name, you have to name the function because
so sir, I have to say let, or we can just put y equal whatever.
No, because they never give you that. That's the problem, you know, they never give you. So you introducing that to them now, you have to tell them, say, boy, you're making this with this.
That's so
extra. No man, it's not extra. Agree with me. Math is a language, and it matters what it is. you know, sometimes you go use some big words and you use the big words out of place. There's don't know how true it is, but then tell some like one person. So the pastor wasn't going to be at church because of other engagement. Yeah, man. But it's real. It's a church joke I hear, so I'm going to give the church joke. it is pulpitable, and the poor person get one big word and no how to use a big word, and because person wasn't going to be in church, person says that he is going to have a prostitute preacher. Because he's not going to be there, right? So which word person was supposed to use? Substitute, and that's the problem. So sometimes we use some words that you know, things just happen, and then everybody was like, now we know what the person has on his headspace.
Oh, good.
All right, so let me show you something here. So, anyway, I guess it's some worldly on, trying to make the church look bad. So that's why them come up with that sick joke about the church.
You find it funny, do it, sir?
I'm really kind of laugh, roll over on the floor, and they're done. They're done. All right, let's go. So, again, I have just adjusted the document all the way up to page 2, right? So look at this now. So I'm giving you this question here. Differentiate this function. Oh crap! I figured that it was a. Sorry, never mind. Hold on. It's a word. It's a.
Cancel.
No. I need to save the document. It was a read only file, and I have to save because this system has a mind of its own, and I don't want to lose my information because I don't want you guys to hear me cry over the system because I know Sash can laugh after me and say, "Geez, All right, let's go. So look at this question. These two questions are the same. So this is Kelvita working this question. I have to share her when she listen to the recording. So Kelvita did the question right here. All right. And then Aviana decided that she went to the question here, but she don't like how Sir always use y and f of x. She decides to use h. So she says let h of x be equal to that. And then h dash of x is going to be equal to that. No, this is correct. All right. So you have to name the function. Put it this way, final example. So this is a real example. After 9/11, I missed 9/11 by the skin of my teeth. I was in Washington, DC up to the Monday, up to the day before the Twin Tower crash, and got on a late flight, a very late flight to Jamaica. And the following morning, when I was running upstairs to go into office, I saw everybody running downstairs to go to the staff room to watch the TV. And I said, oh my goodness, there's a staff meeting that I'm late for. So I am running upstairs to drop down my stuff to run back downstairs. And then all I can hear is Spears screaming. I was like, what on earth is happening? And then my phone rang and, family members were saying, you just missed it. Everything is shut down. No train not running, no bus not running. I am walking home. I said, there's no way you can walk home. Them say, I know, but this is just a reality. Now, let us look at the truth of the matter. So after 9/11, I was terrified to fly. Terrified to fly. And I remember after getting over my fear, I think the first time I did it, I flew after 9/11 was to go to a math conference. And I did some insurance. I said, should in case something happen, at least my loved ones can put me away nicely. So I did some insurance on the flight, etc., etc. And then when I said, oh, it is safe now, I don't have to do this thing again. I remember going to a particular state and I had to go to a particular bank to do a particular transaction. Sat down. Them the times there was a big old blue passport. Used to hate walk with it to say, Jesus, odious even. And I have the big old blue passport and sat in the bank and a nice little Trini person called me and said, next thing I went and did the stuff and told her what transaction I was doing and she asked me my name and I'm saying, why is she asking my name and she has a passport with everything inside here. So, I was trying to be pleasant and I gave her my first name and my last name. And then she said, sir, confirm your middle name for me, please. And I told her. And then I can't say to you what it is that she said. But she said something. I was like, oh, huh. And I was like, Jesus, Father, I was wrong now. And she pushed back her chair and said, sir, can you give me a minute? I said, no. Well, what is the problem? She said, no, sir. Give me a minute. I'm going to sit down and I said, Jesus. Right about now, everything inside my stomach started to liquefy. So I had to be, tightening the pants with a little, should in case anything, happens. And I was like, what on earth is happening? And she came back and I was like, why did you just move from me immediately? And she says to me, sir, on my system, there is another person that has your first name, your middle name, and your last name. No, my last name is not very common. So I said to myself, this is not funny. I was like, then suppose them I look for the terrorist no, and that person that was a terrorist, I made them gone with no Jesus. And I said to myself, okay, sit down, don't run because you run, chances are police out there and use black man and then they shoot you. So just sit down on the car. So I said to myself, okay, what is going to happen now? And then she said, sir, can you confirm your address? And I gave her the address. And she said, my goodness, your twin also lives in this particular state. I was like, are you serious? And she says, yes. And what differentiated us was the date of birth. The date of birth was what differentiated us. And you know what I did? I said to her that I'm perfectly fine. I don't need to complete this transaction. I'm going to come out of the place, jump in the car and drive, go about my business. I didn't want to do no other transaction. What's the point I'm making? Your identity, your name is very important. Extremely important.
Sir?
Yes, please.
Let me tell you my story.
No, man, go through, man.
My name is Andrew B. Cameron.
ABC.
ABC, yes. So now, my account was locked, so I called one of my friends them. I said, listen, unlock my account for me, please. I'm gonna know why it locked. And him unlock the account. Every time I try for sign in, nothing go on. You understand? You know what happened? There is a manager in my company named Andrew Cameron as well. So we have the same name.
Oh no.
The only thing what differentiate us is
the
middle name, and the employee number. See, when time I go through security and them take up my ID because the middle name is the B is not there. They look at my when I say Andrew Cameron, and look upon me and look at my ID. Look up on me, look up on my ID and say, you never passed 3 years already.
You're twin. Yeah.
No, serious thing. I actually see him. Him working in the engineering department. Trust me, we always have a little conversation about it. He call me the bogus Cameron.
No, but no, it's a serious thing, you know, Andrew.
I know it's a serious thing. Persons have sent me emails destined for him to me.
Absolutely. Go ahead.
Yeah, them send an email. Even one time payroll even make a mistake and send it to me.
All right, no, not gonna further because me sure say him supposed to get. Andrew, at this point in time, this is my salary because it's my name, so right?
No, give back in, sir.
No, me not give back. Because as far as I know, this is my name. As far as I know, this is my name. And you no, me not give back that one yet. No, but it's a real talk. I mean, of course, my wife took my name, and you know, she works. When she moved from one job into that new job, there is somebody with the same first name and last name, and you know, based on her position when she moved into the bank, she's getting emails that was destined for somebody else, and there was a whole lot of mix-up. So what they have to now do is not only use first name, last name, but have to use first name, middle initial, and last name. Come on, it's very serious. So listen to what I'm saying to you. So Ryan, you started this conversation, and it's a very good conversation. This is why I sort of love when you have conversations that easy. So just imagine 4x squared plus 3x minus 1 getting confused with f of x equals to that and h of x equals to that. All right. So you have to give the function a name when it is not named. If the function is named in this case, like g of x, you notice I don't have to say let the function be equal to that because it is already named. All right. Now it is important, and the final thing I'm going to say on this is mathematics is a language, and just as how you communicate in other areas, when you communicate in Java and you communicate in programming and you communicate in English language, is the same way we communicate in mathematics, right? And the communication has to be. So I can't say the boys has 2 books because if you say grammatically that's incorrect. A single subject is a single verb. So if you say boys, it must be have. If you say a single subject now, a boy, it has to be has. right? So just as how you have to connect those dots in the English language, you have to also connect the dots in mathematics. And this is one of the dots that we need to connect in mathematics. So it's really a language. And my task here is not just to come and teach you how to solve a question, but for you to be able to understand it, because who to tell? Sometime later, you may very well be called upon to teach a course or to help your children or to help a sibling or a friend. And you must understand what it is that you're doing. All right. So thank you, Ryan. It is important. Now that we get the importance of Android John Star. It couldn't be like a Christmas when the other AC I get bonus, man. No, what am I do that one day? They might have to take out the money little by little over 1 year. Because we can't get them at that all.
But all them are going to take it out, sir.
Worse if Andrew
Them can't go back in your account.
No, but I mean, they would call it to payroll. Will call it back to say that you're paid in
And
error.
them pay you. They mean them can go in your account. So you see a pay short.
They just have to call it a loss.
No, they might pay, so they're going to take it out little by little. They won't take it out one time, but they will take it out little by little.
They will have to go on the bar and get it back,
Ryan, don't talk a secret here. All right, let's go. So
a story time today.
I'm going to tell you the truth. I kind of really appreciate the lightness of the class because, I was really very down before. So later came back on and I signed on from pretty early. So thank you. You're a wonderful bunch of students. All right, so let's continue though. I did something here. Okay, right. So I'm going to differentiate it now. So dy by dx. I did get 20x to the fourth, and that's correct. 20x to the fourth is correct. Now, I am going to just put this up, and then I'm going to. So that's the first term that I have differentiated, and I want you to work with me now in differentiating the second term. So put it this way: if you got the question like this, and this term alone is the correct term, trust me, you get a mark for this because you would have actually done a piece of the question correctly. All right. So this is one piece. So let us go, and this is what the chain rule is. The chain rule really says that I'm going to be differentiating it term by term. All right. So you will get a mark for each term that is correctly differentiated. So if this is all that you did for the question, you won't get 0. And that's one of the things that you'll see on the paper. So sometimes, like especially for the first principles differentiation, some students, when they wrote the parentheses with a minus f of x, some students just remove the parentheses without multiplying that the contents of the parentheses by the minus sign. I recognize that because I don't math for answers. I read through your question, and this is why this one student in the class, I know again, cuss me angry to say, boy, sir, you stay buddy, but I just had to do it. The truth of the matter is, when you have to be able to continue speaking the language, and once that error was made there, I would have penalized you for that point. And if it followed through with the question, like there was a student who did something and should have had 12h minus 7h to give you 5h over, which would have been x plus 6 all squares. And the student didn't realize that the 7h up top was not cancelled out and just carried the 12h there. Some of you will see your paper, see FT. FT as in Frank Taylor. That means follow through. So it means that the question, you don't have the correct stuff, but because you would have made a mistake up top, but the mistake that you made up top was correctly used to complete the question. So I would have given you the marks for those. So I don't mark for answer, because if I mark for answer, the student would have gotten maybe 0 out of 8 for that question. But the student may end up with a 4 out of 8 or a 5 out of 8 or a 6 out of 8, because I'm looking for the methodology, which is why it's important that you write your steps. So even though the question is wrong, once it is that you write your steps, because remember sometimes you may have to do a little point up top of the question, and you have to go use that stop up top to carry through for the rest of the question. No, I can't give you 0 if you just make a 1 mistake up here. If the methodology is correct with that error from up top, come right down, you can get as many as 7 out of 8. I just penalize it for that point. All right? That's how I mark. That's how we mark when we're marking CXCs. That's how I expect my other lecturers to mark as I have gone through with them. So in this case, if you stopped right here, you'd have gotten if it's a 1 mark for here, you'd have gotten 1 mark out of 5 for argument's sake. All right, but let's go ahead now. I really hope you follow me now, because I'm taking my time with this question, because I really want you guys to understand what is happening. All right, so let's go. So I'm going to be go ahead.
Actually, do this part when we think we do it wrong, so we just stop.
All right, no problem. All right. So this is what we're going to do now. We're going to differentiate here. Now, let me just remind you. When I'm differentiating this, remember it's a power. This is a power. The 1 here, we're going to come in front of the 1 here. We're going to write this back, subtract this from the power, and then differentiate. Remember the 3 step? But this is the first step. Carry this down in front of this. 1 step. We're going to write it back and put the -1 from it is the second step. And then we're going to differentiate on the inside, the third step. So watch me now. Use this one up here, so while I have my black screen up there. So this is going to become now, this is now going to become 1/2, bam, 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 to the -1/2. And then I'm going to say times, what's the differential of the inside of the parentheses?
6x. 6x, sir.
Good job. So, hold on. All right, so let us go again, because I'm sure somebody didn't see this. Let me put on my spotlight so I can show you. When I finish this, I want you guys to fully understand what is happening. So we're looking at this term. This is a term that we are concentrating on, right? You know, I will just tell you. I just muted it a while ago because a parent was calling me, and I'm sure why the parent is calling me. The amount of calls I got today, and you know, let's go here. So this 1/2 is going to be multiplying down here. So that's the first step. See the 1/2 here? The second step is that I'm going to write back the function and reduce the power by 1. So I write back the function right here, so, and I'm reducing the power by 1. 1/2 minus 1 is going to be -1/2. And then the third step is to differentiate what is inside the parentheses, and that is my 6x. That is done, right? So that part is finished. No, by the way, before I say no, is there any question? No, hear me out. Before you answer me, we're not going to say again. When I ask a question, I want to know honestly answer me. This is not a boasting game to say you're not asking a question in class. I want you to ask me the questions and ask me the questions so that I can answer you. Please, students. So hear me out. Are there any questions? Everybody okay with what it is that you're seeing? Is there something that you're not seeing?
I'm fine, sir.
Comprende, señor.
Oh, very nice. Si habla español. All right, let's go. All right, so I'm color coding my terms. So that is my first term here. Then my second term, I'm differentiating, and then I'm going to differentiate them last. Yes, honey bunches.
I'm a blind, so can I use brighter colors, please?
Sure, just crop this there. So sure, man. All right, no problem, dear. I will do just that for you. And you're not blind either. Don't
Sir,
call
you
on
can zoom in too, please.
Will do for you. Jeez,
It's called bigified.
Bigified, that's right. Say bigified, sir.
Okay, sir.
All right. So I'm using the color that is on the wrong side of North Street. But anyway, that's another conversation. Let's go.
It's
all right.
true.
So yeah, man, I agree with you, man. All right, so let's go. So this is the first differentiation right here. This my second term is going to be this piece right here. All of this piece. Remember, it's a 3-prong calculation. This 1/2 is taken from here to here. That's the first step. My second step is to write back my function and reduce the power by 1. See it in here, so bam. And then my third step is the differentiation of inside the parentheses, which is going to be my 6x. So that is done. Sir, you're not going to say plus something? No, because it's just this term. So it's not a product. It's just this one term. Then I'm going to be differentiating now. See, I told you. I told the parent to what's happening. Okay. was concerned that okay, so let's respond to you, sir. Thank you, sir. All right, so this is it now. So I'm differentiating the last term. I'm differentiating the last term, and the last term is going to be, oh, but this is a power rule again, sir. So it's the same 3-prong. All right, let us look at this. 3-prong. So what is going to happen? Let us change the color from here, and I'm going to put this color into, say, this bright color, so that all those who don't see the bigify stuff will see this. So what I'm going to have now is that 3 is going to come in front of that. I'm going to have the 3 in front, and come on, don't disappoint me now. I'm going to have my 3 in front, and then I'm going to have my 2x plus 1 to the second power. Why to the second power, sir? Because remember, you know, we're reducing it by 1. We're reducing it by 1. And then when I differentiate the inside of the parentheses, I'm going to get 2. So look at what happens now. This 3 is going to come in front of here, which is this 3. And then I'm going to be I'm going to be reducing this parenthesis by 1. So it now becomes 2x squared, 2x plus 1 to the second power. And then I'm going to be differentiating the inside of the parentheses. Of course, the differentiation of my constant 1 is going to be 0, and the differentiation of 2x is going to be 2. So my differentiation ends right here. But guess what? This is not really the end per se of the question. We need to kind of fix it up. Before we fix it up, anybody got this up to this portion correct?
Yes, sir.
Very nice. Sir. Very nice, very nice, very nice. Now, so look at what sir is going to do. Sir is going to just fix up this in such a way. Oh Jesus, who asked the question?
Oh, that's my problem, you know, when you're ready to fix it.
Yeah, was it you who asked the question last time about? All right, so look at what we're doing. Look at what we're doing, and work with me. It's really not difficult. 1/2 times 6, because remember all of this in purple is one term, and that's why I color coded. So this 1/2 times 6 gives me what?
3x.
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 Excellent. So that is going to give me 3x. All right, very nice. You see, when you can't tell me, when you not learn how online, you know. Me can boast about you like I was boasting about you guys today. I said, don't play with my students. All right, when you can't see the screen, my black screen is still there, but let us look at the one up top here as I type. So I am multiplying this 6x by this 1/2, and I'm going to get 3x, correct. And this 2 is going to be multiplied by this 3 to give me what?
6.
Very good, very good, excellent. And that is going to be that line. And look at it. That's all I did. I just reducing here to here because I fixed it up. And then I'm going to copy that line because I'm going to go through again now to do some more. Oh, but sir, is only one more thing you can do. What one thing is left for me to do?
I have to get rid of the one that we just work out.
Which
Get
one?
rid of the negative power.
Get rid of the negative power. Very good. I'm getting rid of the negative power, Krishna. The negative power is what I don't want. So division. So this is what sir going to do now. I'm trying to get rid of the negative power. So watch this step and tell me if you agree with that step. Say it again, please.
Yes, sir.
That's it, Charlene.
This was a question. This was a question that I had, sir. Because
what's what, Charlene?
Continue,
girl.
Yeah. The previous ones that you were working out with the 1 over the 3x squared.
Mm-hmm.
I was wondering if it's a number and not just 1. You can understand what I'm saying.
No, I'm lost. Talk to me again, honey.
No, you had 1 over the
Oh, the reciprocal. Okay, yeah. Got you.
Yeah, so now I realize it's any number over the reciprocal, let's say, sir.
Yeah, right. No, so okay, so let me just save. Let me just save. Right, let me just save what I have there, Sash. And this is it. So all I'm doing here is this. Where am I, Lord? Where am I? Okay. Right. All I'm doing here is this piece that is raised to the negative half. You remember this is a multiplication, you know. So this piece I'm not interested in because this 3x is still 3x. and it remains 3x when it stays in the numerator. If I put this 3x in the denominator, it becomes 1 over 3x, which is 1/3 x to the minus 1, which is a different number than this one. But this here is the only thing that when reciprocated now becomes a positive 1/2. And this is it that is here. That's the only thing I'm going to put in the denominator. You notice anybody did it right here? Why? Because the power here is positive. The power there is positive, right?
Yeah.
And then the final digga step stash. Look at this stash. We know, look at what Sir did. Oh, come on. Look at what Sir did up top. What Sir did was to convert this, the root of 3x squared minus 1 to 3x to the,
So you revert back to
yeah, man. Yes, man. So I put it back right here. So, and this now will be my final answer. Let me put all of this in red to show that is my final answer. That's my final answer. And you're good to go right there. You're good to go right there, right? So I want you to work with me. It really isn't difficult.
So wait, before you answer, sir. So you said that the answer, this is the answer right here, it done?
It done. Done.
So how would you know that it's done?
All right. Okay. Mute for me, please. All right. Thank you. All right. Good question, sir. How do you know that it's now done? There's nothing that is common here. The x terms are not common. Well, you have something that is common here, that is common here. You don't have, okay. You don't have anything in this function that is common. But sir, 6 and 20 have something in common, sir, because it can say 2 and it can say 2. Yeah. But 3 is not, the whole number 3 is not common to 20. But sir, 3 is common to 6. Yeah, but we want something will common to 1 term, 2 terms, and 3 terms. But sir, the x to the 4th and the x common, sir. But the x no out here, so will common. You follow what I'm saying? So I have 3 terms that are 3 different and independent terms, right? Now, watch me. The general rule that I would say, this is original question. The original question was given as a chain rule, and I'm writing back my answer in a chain form. The original question was given as a chain rule, and I'm writing back my answer in a chain form. Can you see what I'm doing right here?
Mm-hmm.
Yeah, man. And I will tell you why. And this is the format that I want you to do. So whenever you get a question of this nature, I'm going to ask that you don't try and get creative and go and do some gymnastic mathematics. Leave this as it is. Because the next topic that we're going to be moving into tonight is a topic that is called integration, which is the reverse of differentiation.
Oh,
so what? Yeah, man. But don't worry about it. I bet you're not going to like it. I promise you. Look at what is happening. So I can actually integrate this function to see if I get back this function. I can integrate this function to see if I get back this function, and I can integrate this function to see if I get back this function. So look in here. From here so to here so is differentiation, and then from here so up to here so is integration. All right. So when we get to that, we will cross it. But excellent question, sir. But maybe I try to factor out something like what you did normally factor out something. No, the question was given in a chain format. Let us leave our answer in a chain format, right? But I'm going to congratulate you though. Whoever asked the question, you didn't pick up the voice, but whoever asked the question, Onika, I'm very proud of you. I'm going to tell you why. Because it is saying to me that you're thinking outside the box. You're following what it is that your teacher is doing, and you're trying to emulate, trying to do what it is that you're supposed to do. But sir is saying to you that you're good to go at this point. All right, very good, excellent. All right. Now,
sir, what it messed me up is never know, because all right, so my mind went wild when I saw these questions. So after I do the first line of differentiation, well, after I do the differentiation,
this line,
I know I'm fixing it up. You know how you divide the 6x by a half? My brain has said there's no x beside the half, so them can't cancel each other. So that is where. Yeah.
Okay. All right. Stick up in there. You may have another question, but stick up in there. Let me just correct something here. All right. So I appreciate what it is that you're saying, but look here, honey bunches. What is this half 1/2 doing to the 3x squared minus 1 to the negative 1/2? Tell me.
Multiply.
Very good. It is multiplying. And then now, Karika, this piece is what doing to what? To this piece.
Multiply.
Very good. So once it is being multiplied, multiplication is commutative. What do you mean by that, sir? 2 times 3 is 6, but 3 times 2 is also 6. So you're just going to go ahead and do the multiplication. And then a very smart student says, sir, do you always, when you multiply, do you always get a whole number? And I said, no. Sometimes the multiplying will end up with a fractional form. You'll end up with a fractional form. All right? But yes, Yannick, I hear you, and I also appreciate that.
That's what I have a fraction. So I have 6x over 2 instead of 3x.
And that's fine. That's fine. The most I'll do is maybe penalize it for 1 mark to say that you need to simplify your answer, but that's perfectly fine, 100%.
So, sir, what if it was the answer like, what if the 6x was like 5x?
5x, it will be 5x over 2. That's the point I'm making. It will be 5x over 2. Yeah, ma'am.
So don't go decimally. Just
no, sir. No,
so once it is into the number that is to the side, it can
very good. Cancel it out. That's the point I'm making, Yanni. Very good.
Okay.
All right. So
sorry, I skipped that question. I didn't hear. What did Yannick said, sir?
No, so Yannick was saying that, oh, sir, based on the question that Karika just asked a while ago, sir, what is this for 5x? That means you'd have had 5x over 2. And I said, yes. And then Yannick said, oh, that means, sir, anytime it can simplify it, because when Yannick got 6x over 2. And I'm saying that she's not wrong. And then she said, oh, sir, so what you're now saying is once it can be simplified, simplify it. And I'm saying, very good. Once it can be simplified, simplify it.
Okay, sir.
Yeah, ma'am. All right, let me just stop and just encourage somebody, because I know somebody in the class is a little bit, flustered and saying that, I was sir, I do, and can't bother with this and something there. Now remember, don't agree with me, please. This is not a time that you're supposed to agree. Remember now, we are in this thing together, and none of us will leave anyone behind. And what I'm happy about, the ones who often participate in class, I am enjoying those questions, because what it is doing, oh Jesus, here I come. My old man are calling me to say it. All right, because guess what? He must hear the thing. Give me half a second, please.
Sir, same old man I call him.
Yeah, him father. Yeah, but the idea is
boy.
So if I didn't song him, would I call him young man?
Please, is that?
I thought that was white people stuff. I'm sorry.
It is a term.
I know it's a term, but all the things that white people use it.
But well, I'm not gonna say just white people, but I usually like American people.
You just called me white a while ago, Karika?
Karika. No,
Right,
what a way my name easy to call.
Yeah, trust me. I have had students from overseas who are calling me to say, sir, are you okay? And
Sir, are you okay?
I am trying
sir,
to.
I want to at the second time you say if people are calling and if you're okay.
All right,
because
never mind.
what
Sir,
happened
with me nine,
Jay never read the thing you sent.
Which thing?
Sasha, you never read the song with Karika sent.
Oh.
Oh, Jesus.
I am offended. Sasha,
Right.
I am very offended.
Let me go read.
Okay, so know that you're going to be reading it, you'll understand what I'm talking about. We are recorded, and I don't want to
get into it.
Right. But just to let you know, forgive me. When my family members are calling, I have to just to let them know that not good. All right, let's go. All right, yeah. So yeah, man. So we can move on to the other. Whoa. Somebody actually set this question for students to do. Come on.
Yeah, right? I wonder who did that.
I have no clue. My twin. I have no clue. Ryan, I'm not hearing from you. Are you okay, Papa?
I'm good, sir. I'm good.
Nice. And Miss Russell, are you okay?
Yes, sir.
Thank you, please.
I'm good as well, sir. Medea.
Nice,
Wow.
very nice, very nice, very nice.
For them, you better go call next.
You
Right?
understand? What does that come up? Is it?
I say some work to go do, you know. So.
Oh yeah. And all of us, myself, to have to set some more work for now. All right, good. And Krishna, I hear from Krishna. I still not hearing from Jeremy, but you know, make him stay. I know how to get through to him.
When sir don't know doing a triple CJ can't frighten no, you know.
No, I'm making tell you no. Straight up.
Straight up.
Chedi, okay?
Yes, sir, I'm fine.
Okay. All right, so let's go.
No, the question you sir.
I don't know who. Yeah, it just look way down. All right, tell me which method have you used. Tell me which method we use.
The quotient, sir.
Quotient.
Quotient. Very good. So using the quotient rule. All right. Now, oh Jesus, have mercy. So we're going to rearrange. REARRANGE. Now, you know why I'm saying why I'm doing all of this, so that it becomes innate. It becomes a part of you. The methodology that you use, when it is that you are doing the question, so that when you get the question on your own, you know that sir always do this first, then you do this second, then you do this third. That's what I want you to be doing. I want you to be following the procedure. The solution to the question is very procedural. All right. Yes, there may be one or two steps that you could possibly leave out, but because I'm doing my explanation, you know how long this question takes us to do? Because I could run through the question and show up that I know how to do the question, but that's not the aim of the game. The aim is to get you to a point where it is that you can do the question, so that at the end of the semester, you're better than I am in solving the questions. Eh?
I have to write up my arrows, so I like the pace.
Very nice, excellent, thank you. All right, so we're going to rearrange this thing here now, because we recognize that we have a square root here. So answer say when you get the square root, rearrange something. Now start with something before you rearrange it. So sir say, and so me I go do this something because me go pass the course. All right, so look at my rearrangement. So that's what I'm doing. Easy, simple rearrangement. All right. So when I rearrange that, I'm just going to copy that. Matter of fact, is everybody following me so far?
Yes, sir.
Okay,
yes,
good.
Sir.
Now,
Yes, sir.
excellent. Now, look at what is going to happen. I am differentiating a quotient. You know the quotient rule. The quotient rule says the denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares. So denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares. Watch me. It's the denominator times the differentiation of the numerator. So what, when I differentiate the numerator, what do I get?
18x.
Very good. 18x minus the numerator 9x squared times the differentiation of the denominator. When I differentiate the denominator, what do I get?
I have to do the power rule, sir.
Right, and I'm going to get what? Tell me what I'm going to get.
Half.
Very good. A half, then what?
5x squared.
5x squared to
the
negative
negative
a half
times
10x.
Love it. Love it. Love it.
Oh my God.
I'm happy that you've met him. Yeah, man. All right. So is somebody seeing something here?
I believe that like the square root that tricked me.
Ah, trust me.
I did have it now. The first one, I'm forget it.
Times the inside, which is 10x, don't?
Yes, sir.
Times 10x. Very good. I'm happy that you can. Over the denominator square. Stark truth.
Yes, sir.
Yes, sir.
Nice. Come on over there to me.
sir, the quotient rule, you said the differential of the denominator times the numerator.
No.
This look exactly like how would I do it? For me, it's wrong.
Ow.
No, what you said a while ago, you said the denominator times the numerator is times the differentiation of the numerator. So say it right for me. So go again.
Oh, so hold on, because I said the differentiation of the denominator.
No.
So
look,
it is the denominator.
Denominator, very good. Times the differentiation of the
numerator.
Right. Minus the numerator
times the
differentiation of the denominator. And you can see there's 3 steps. 1 step, then 2 steps, then 3 steps, all over the denominator squares. So this here, that portion there.
Can you write it backwards?
Well, as long as it makes sense, let me just show you the differentiation ends right there in blue. Right here in blue, the differentiation ends, but remember, you have to fix it up. If you leave it like this, you won't get full marks, because part of the problem is how it is that you're going to communicate your information. So what is going to happen? Let me do this part. All right, let me just take it in stages. So all I'm going to do right here, look at the one in blue as I'm speaking, so you can make reference to it, and then you'll see my adjusted answer. So there's nothing for me to cancel out with the 18x. I'm just going to put the 18x in front. There's nothing for me to cancel out. Now, if you look at the other part, look. So this 18x, can you see my spotlight?
Yes, sir.
So this 18x has nothing to cancel out with, so I'm removing this 18x and just putting it in front. But watch this last piece down here. 9 times a half, that's going to be 9 over 2. Make sure about that multiplication. I'm going to say a half times 10 is how much? It's a 5.
5.
How about this 5 times 9?
35.
45. And then it's going to x how much?
Cube.
Very nice. It's going to be x cubed. Excellente. 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 And then you're going to have that. And then watch this now. Watch this. When I have a base raised to a power, which in turn is raised to another power, what do I do with the powers?
Multiply.
Multiply, sir.
And 2 halves make a?
Whole.
Oh, no,
sir.
no, not H-O-L-E. Say W-H-O-L-E. Out of order. Say W-H-O-L-E. You remember Ryan is in the class, you know, so you have to be careful of what you say.
Oh boy.
Not just Ryan, sir.
No, geez, Jermaine too, yeah.
But no,
Yeah,
say I call him name.
Yeah, forget Jermaine is there. It's true. All right, let's go. So this is so look at how the denominator cancel out nicely. It's not this 2 we're multiplying by, no. Jesus, I thank you, Lord, for this question. Another 2 years so we are multiplying, not this. We are multiplying this 1/2.
Receipt, man, sir.
No, somebody else I got to say something else.
We're not troubling the power in the bracket.
We're not trouble the powers, the power, P-O-W-E-R. What do you say? Inner
the bracket.
The B-R-A-C-K-E-T. Serious, let me leave it.
Unless it's 1, sir. That's what you said.
No, man. No, I'm just saying that because what I'm coming to you, Papa. Let me just fix up this thing here.
Make it
It's
smaller.
like Erika, it's like, sir, remember one bad experience with one paper.
It sounds so
yeah, man. So you know, so sir, I try fix it up so that it don't come back. This bad experience don't come back again. All right. So look at what is happening. So remember, you know, we're not trouble with inside of the parentheses. Not trouble that. It's just a powers. This is a pause. Yeah, outside. Yeah, man.
Outside.
Yeah, man. Yeah. Right. Okay. So let's go now. So this is what it is that we have so far. And now, oh goodness, who was it that asked the question? All right. So somebody, I think it was Kerika who asked the question. And forgive me if it's not Kerika, but I think Kerika asked the question. Sir, I went further now because I tried to do the factorization. Now let me show you. Oh, it's unequal. All right, thank you. So look at what is happening here now. Compare this to what it is that we're looking at here now. And agree with me. Don't you see 5x squared raised to a power in the same something up here, so? Talk through.
And in the denominator.
Yes, sir.
And it is
Yes,
also
sir.
in the denominator
So we
down.
can cancel.
So something seem like we can cancel out somewhere because we have the things we look alike. So right here and then, none of you should leave this as your final answer because you're seeing that something can reduce something and something can go on with something. All right, let's go. Let's go. Hold on.
Opens the wash.
All right, so let us look at this now. So what I'm going to do is I recognize that the 5x, let me see how many of you are really learning. What am I going to be factoring out?
Sir, you can just
5x squared raised to the negative of.
Why am I doing that?
It's the
wait, hold
smaller of
on,
the
what?
two.
Very
There's
good.
a negative.
Yes, there's a negative.
Oh, at the black make it look like one something. I never
Yeah,
noticed that.
right. So the negative. So
Cancel out the smaller one.
right. So I'm canceling this one. Is there anything else that I can factor out?
Sir, 9 come on to 18x and
Is there anything else?
45x.
9x, sir.
9x. Very good. Very good. Love it. Love it, my students. Love it. Ryan, I'm not hearing you. Wake up.
We are soaking in, sir.
Okay, good. And by the way, what is soaking in? The white? Oh, no, don't answer.
No.
All right, let's go. All right. So very good. I love what it is that I'm hearing. So again, you guys are remembering REMEM. Remember that we FACTOR the smaller of the two. All right. So this is exactly what is happening. So we're factorizing this one. I'm happy. Let me fix this because I heard somebody say, Zakarika, who said, you never see that one, they look something so it kind of look like. So let me put a little space between that and that. So you kind of see the negative sign here, I'm taking the smaller of the two. So you see it now, right?
Yes, sir.
Right. So what is happening now? I'm taking out the 5x to the negative a half. See it right here? So let me fix that one also. So I'm taking out the 5x to the negative a half. And then when I do that, I am going to say, is there anything else that just come on? Yawn. 9. Because 9 can go into 18 and 9 can go into 45. Is there anything else come on? Yeah, x, because I have an x here and I have an x cubed. And again, remember, I'm taking the small of the two. So I can't take out x cubed. I'm taking out the x. So now that I've taken out everything, I'm going to see what is left. What is left now when I take out 9? Tell me what is left.
This part always confusing, sir, to be honest.
All right. Okay.
So you're taking 9 out alone, as in overall, or just
I'm taking 9. I'm taking 9 overall. Right. No man. I just copied it and then I come back because I want you to see what is happening.
Okay.
All right. So this is what I'm saying. So when I factor out the 9x, I'm happy that you see that this is what is being factored. Let me just highlight the factors. Let me just highlight what it is that I'm factoring out. So I've highlighted the factor. Now I'm going to say, what do I multiply by this factor here to give it back up here? So 9x times 2 is 18x. And 5x squared to the negative 1/2 times 5x squared to the first power. When I multiply these two, when I'm multiplying, and the bases are the same, I add my powers. Negative 1/2 plus 1 is positive 1/2. See it here, so? Positive 1/2. Everybody see that?
No.
Yes.
Work with me. So when I'm multiplying and the bases are the same, I add my powers. 5x squared and 5x squared are common. So this 5x squared is being raised to the first power. And 5x squared to the negative 1/2 times 5x squared to the positive 1/2. The bases are the same. What's the base, sir? The base is 5x squared. So because I'm multiplying and the bases are the same, I'm going to be adding my powers. So I'm going to be saying, what is 1/2? Negative 1/2 plus 1. It's going to be 1/2. See the 1/2 here? So when I multiply all of this by all of this, I will get back this up here. Are you seeing that? I don't like that.
Yes, sir.
That's that, sir. Read again.
All right. And at no point in time when you ask me a question, copy. I want any of you to think that I am frustrated because you're not seeing it. That's not who I am. All right. So just be around with me as I try to do something here.
Sir,
Yes, love.
if it was just the x that I could factor out, would you just leave it alone?
Say it again. If it was which x? This x?
All right, so instead of a 18x, you had a 19x. You would you still factor out the x, or you just leave it alone?
Yeah. I just factor the x. Very good. So you're saying if I had 19x and then the 45 over there, it is just the x, yeah, man, because there's nothing that will be common. Yeah.
No, I'm asking if you have to factor out the x.
Yeah, man,
In that
because
case.
because the x is common here and the x is common there. Yeah, man.
Okay.
You might have to find. Yes, please go ahead.
3x could have worked as well.
If I put 3, it will be an incomplete factorization because I'm going to have 6 left and I'm going to have 15 here, but something can go between 6 and 15. You follow me?
Yes, sir. Yes.
Yeah, man.
Sir, okay, in that step in the second rule, you said the 5x squared to the negative 1/2. You say cancel with the denominator?
No, we don't reach the denominator yet on the bunches.
Oh,
We don't reach the denominator yet.
okay.
All right. See if this makes any sense. Note. What I'm saying to you is when I'm multiplying 5x to the 1/2 to the negative 1/2, multiply by 5x squared to the first power. When I'm multiplying and the bases are the same, I'm adding my powers. So this number becomes 5x squared to the negative 1/2 plus 1. Negative 1/2 plus 1. And then I should write what that is.
Or 1 minus half.
Or 1 minus half. Same difference. Very good. Copy. Equal this. And then I'm going to have just 1/2. And that's what I'm gonna and that's what I'm gonna have. Hold on. Yeah, that's what I'm gonna have.
No, sir.
Very nice, very nice. And this is what we're about. We're about for clarification, so it is that you can see what I've won. No child would be left behind in this class. Right. All right, and then now, what it is that we're saying. So we did this first piece here. What it is that we're saying now is 9x times 9 times 5 is 45, and x times x squared is x cubed, and this 5x to the second power raised to the negative 1/2 is the same thing as here. So when I multiply all of this by all of this in blue, I get back all of this term. Let's go again.
Sir, one moment.
You don't have the power.
I'm so sorry, but then sir, I don't see the negative after. Can you repeat that one more time, sir? What exactly? Don't do the way, the backwards way, sir. What is it?
You don't see this?
No, sir, not there. My door is wouldn't get back over there, sir.
You don't, okay. All right, do me a
I
favor.
don't the back way.
Hold on. Who was that talking to me? Kariko?
Onika.
Onika. All right, Onika. All right, Onika. Ooh, Onika, your background is very, very, very loud. I am having a difficulty hearing exactly what it is that you're asking. So I'm going to ask you to just, I don't know if you can shift. But I want to hear your question. So can you ask the question again, please? Yeah, I hear you now. Go ahead.
Sorry, the question, sir. I was saying I don't see how you get the 2 bracket 5x without nothing there, right there, sir? Yes, sir.
Right,
I'm
okay.
saying
Yep,
I see when
I hear you. I hear you. Mute. All right. So I hear what it is that you're saying. You said that you see when I do the reverse, but you're not seeing how it is that I move to the 5x squared to the first power here. Okay. So what I'm saying to you is I'm factoring out the smaller of the two. So I'm taking out 5x to the second power raised to the negative 1/2. 5x to the second power raised to the negative 1/2. I'm saying to myself, what do I multiply by this to get this? All right. Let me not use that one as an example just yet, Onika. And the rest of you, I want to watch what is happening. So I'm factoring out some terms. And when I factor out the terms, you will see my factor term here in blue. Her question is, how did I arrive at this? But I'm not going to tell her how I arrived at this. I'm going to show her how I arrived at everything on the inside here. I'm asking myself, what do I multiply by 9x to give me 18x? The answer is 2, don't it?
Yes, sir.
All right, good. So what do I multiply by 5x to the negative 1/2 to give me 5x to the positive 1/2? When the bases are the same, I'm going to add the powers. No, when I add 1 to this negative 1/2, I'm going to get this positive 1/2, which is what I was showing here. When I add this to this, I'm going to get what it is that I want, 5x to the 1/2. So this is what I want, this here is up here, so that means I have to multiply it by this. This is a term that I must multiply it by. That's the term that I must multiply by Nico in order to get this term here, which is what I want up top here. So now, let us look at this now, Nico. When I multiply this first term by my factor, I'm supposed to get like this. Watch me. 9x times 2 is 18x. 5x to the second power times negative 1/2 to the negative 1/2 times 5x squared to the first power, see it right here, so, is going to give me 5x squared to the positive 1/2. See it right here, so. Because this line should follow this line. Sorry, line, other way around. This line down here, so, should follow this line up here, so. So when I'm factoring it out, and when I double check my answer, this is what I'm supposed to be getting. So this times this should give me that. So that's why I'm saying 5x to the negative 1/2 times this 5x squared to the first. See it right here, so. It's going to give me 5x to the second power raised to the 1/2, which is this one up here, so. Anika, unmute and talk to me now, honey.
Okay, sir, understand.
All right, good job. And if you really don't see it, just tell me again. Don't think that you're holding up the class here. That's one of the other things I need to say. If you're not seeing something and I re-explain it and I still not see it, let me know. Because it means that what I thought my explanation would have been clear, I'd have to deep down now to find another explanation so it is that you can get it. All right? So let's go. This last piece, Nika, is easier to see because this term is exactly the same as this term. So remember now, this is what I ultimately want to get. So I'm saying to myself, what do I multiply by 9x to give me 45x cubed. And 9 times 5 is 45. And x times x squared is x cubed. This term times 1 will give me this term up here. So that's how we look at it. You just need to practice a little bit more.
Sir,
And
you know what's a little confusing? Like I get it, but it's like because it looks like two different terms in a way.
Yeah, I see your point. Yeah.
So it's like you want to say, what about the 5x squared to the negative a half times 2?
Yeah, but it's just a factor term. And as I said before, the more of these questions you get, is the more practice and the better understanding that you'll have of it. So I would say to you, Anika, and not just you, but the other students in the class, that once I would have gone through this, pick up the recording, go through it again, pick up your notebook, and try it until it is that you become master of this stuff. Those of you who hear me out, students normally who pass calculus 1 at a C minus struggle through calculus 2. Let me say that slowly. Students who pass calculus 1 at a C minus generally struggle through calculus 2. So students who pass calculus 1 comfortably, calculus 2 is a breeze because it means that the foundation is properly set. And I don't have to be going back through the foundation to say, no man, when you're differentiating a product, it's the first time the second plus the second times the first. Eh? You have that. So I can just spend more time now on the other areas that you possibly, well, that will be new. So just learn this. Those who struggle through calculus 1 will struggle through calculus 2. And if you struggle through calculus 2, the possibility of you failing calculus 2 is going to be even greater. All right? If you go ahead, hon.
So for the negative a half at the line above the last one here, last negative a half up top, is it because you carried over the smallest?
Very good.
You would
excellent. Yes, miss.
Okay.
This is what I factored out. So that's another way of looking at it, Sash. This is what I factored out, honey bunches. So I factored out this one because it's the smaller of the two, so it come right here. So the smaller of the two that I factor out, it means it's not going to be right here. So again, because it's this minute factor out. If I don't want to factor out Sash, it means I'm gonna have nothing right there. So but when I have something right there.
So the minus 5x squared, how is it that the minus comes right there?
All right, watch me now. When I multiply all that is in blue here, with a minus 5x squared, let's see if we get back this up here. So work with me. Negative 5x squared times 9x, negative 5 times 9 is negative 45. Don't.
Yes.
See here, so? And I'm doing it in step by step. X times x cubed, x squared, give me x cubed, don't.
Yes, sir.
And all of that one, will replace with all of this up here. So, as I said before, it just comes with practice, and you'll be fine.
All right, sir.
All right. And again, I'm going to re-emphasize the point. So you see, Sash saw the question a different way, and I explained it a different way, and I'm almost sure that that's Anika saying, okay.
It's Kerika, sir.
Kerika,
sir, Anika, so I like.
Same way, so. And Kerika now seeing something and said, blow, I never look at it like that, So this is what I'm saying, one student, is responsible for the other student's learning, because based on when you ask a question, it triggers off some other thinking. Very nice. All right, let's go. Am I done? Is there anything else you think I can do?
No. Wait,
Yeah,
sir.
Yes,
we can
sir.
cancel out the 5x.
Yeah, man. Oh, thank you, Jesus. No.
So sir, you're gonna leave with
No, don't tell me what I'm gonna leave it yet. Don't tell me what I'm gonna leave it yet, Kerry. Hold on 1 minute on the bunches. So
right.
in the for the mid semester, when you were doing the when you're doing the first principles using the quotient method, I saw people canceling beside addition sign and subtraction sign, which is very illegal. It can't work. People are canceling beside negative sign and positive sign. Watch me.
Sir, say that again. People are doing what?
But this is what I'm going to show you now. I'm seeing people say, this can cancel with this, can cancel with this. You can't cancel side of one negative sign. You can only cancel when it is that you have a factor, meaning that something that is being multiplied. So now I can think of a cancellation because this 5x squared to the negative 1/2 is being multiplied, is being multiplied by out of up here, so I can do a cancellation. So, but
you can't do the 5x,
no,
the negative 5x squared.
You can't, you can't do this with this and then this with that. No, you have to group them first before you can do a cancellation. Remember, you have to first group before you do the cancellation. Group first, then you do the cancellation. Cancellation, remember, work with me. When we cancel something, it means that we're dividing. Talk truth.
Yes, sir.
Yes, sir.
When we cancel, we're dividing, don't?
Yes, sir.
Yeah, man. Now, what's the opposite of division again?
Multiplication.
Absolutely. So it got to be multiplication in before you do the division in. You can't subtraction in or addition in and then when the division in. So you have to do the opposite to it. So you have to make it a product first before you can cancel. Oh, sir, I see what you're saying. So because when we cancel, sir, it means that we're dividing. It means that the thing must be multiplying first because the opposite of multiplication is division. Very good. Yes, that is it.
And then factor out the 5x squared, sir.
Very good. So what is going to happen? What is going to happen now? Remember, this 5x squared is what? Is written to which number?
Negative a half. You need to
Negative a half, sir.
What get rid of it?
Sir, let me tell you, it is going to
down to the bottom.
Good job. Yes,
No,
Miss Kerry.
sir, but what I was asking though, over the second term where you have the 2x times the 5x squared, couldn't you?
Oh, absolutely.
You're going to do that after.
Yeah, absolutely. What is 2 times 5? Yoni?
Repeat.
What is 2 times 5? I know it, but I just want you to talk. 10, yeah, duh. What kind of question that sir asked? You know, it's like calculus. What am I doing?
Sir, sound like Miss Murray a while ago.
Yeah.
Maria the boss, you know?
Yes.
Maria the boss, man. That are my dupes. All right, let's go. Excess really produce some very good lectures. All right, so okay, I didn't hear that one. So let us go. So we're gonna do all of this, and then so I did that rearrangement. Okay, let's go. Okay, and then we are gonna do this, and then 10x squared minus 5x squared is 5x squared, don't it?
Yes.
All right, so I'm gonna have 5x squared right here. So if you agree with me, we see how nicely we are reducing our terms.
Hold on a minute, sir.
No, don't say anything. Don't say nothing. 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 Because I'm sure you don't say nothing. You say anything? Ask the question now, man. Ask the question now. Ask the question now.
Go with the flow.
Ask the question now, no? Ask the question now, Mr.
Sir, why have you so strong?
Because thank you. And this is what I love. You guys are seeing what is happening. This is sir just copy and never change the sign, and then wanna see it now. And want to run off on a mode. And that's very good. Watch this now. Watch this. Watch me. You see, when I started this topic here and I gave it the introduction up here, so the nth root of a to the m. I want you to watch that one here. Boy, sir, I don't know, sir. I don't know what is wrong with you when you write the question in. I don't know myself. Watch this, guys. This 5x squared is being raised. This first term here is being raised to how much power?
1.
Right. And when I multiply these two things, what am I going to get? What is it going to work out to be?
It's all squared.
let me just do that as a notation. No, go square, you know.
Sir, because
sir, I'll go on in a sir, me still
1.5
cancel each other.
They're not gonna cancel each other, no, yon.
Sir, you go group it, sir.
25 export.
What?
Sir, 1. 5x
Jermaine?
squared to the 1.
Excuse me? All right, I'm gonna switch on the serious mode now because we don't know what you're saying. Somebody gave me the correct answer earlier, no?
The 9x over the 5x to the
no, all right, don't say nothing more.
You're going
Watch
to
this.
the square. Then that me did say, sir.
Me never did say you're wrong. Don't me did say somebody said the right answer. Me never say you're wrong. I did say a while ago that somebody said the right answer, but me that hear something that I said don't say nothing else. So watch me now. Remember, say, when you're multiplying and the bases are the same, you add your powers. Now the 5x squared here is being raised to the first power. So because the 5x squared and the 5x squared are the same bases, you're going to be adding your parentheses. You're going to add your index. When we talk about parentheses, you're adding your index or your indices because it's more than 1. So you add 1 plus a half. Let me put that in.
Sir, so that will eventually become 5x cube.
Oh yeah, I can do that. Yeah, I can do that. Hold on, I can do that. Let me just copy this. Oh Lord, what did I do? Oh, I see it.
Turn your camera on.
Sir, best believe some of that book from starting and come. You know, so I'll be a rubbish in there from me. Not like what me do.
You know what I'm happy about though? Is that you give an attempt to the question.
Sir.
Yes, Caribou.
Where the 5x squared to the negative half gone? You say you multiply it. Yeah. Sir, who you talking to?
Sir, Kelvita need to hear the question and
Sorry,
what's
There's not a secret.
See you need show. Okay, Kelvita, I'm sorry, your honey bunches. All right. So what? So Kerika, you're asking where is this 5x squared to the negative 1/2? Watch this. This magically went into the denominator and become this magically to the positive 1/2.
Sir, you know, me see, but me did think you got cancel.
Why go on there, sir?
Right, go down there because we don't want a negative power.
Sir.
So okay, I don't want a negative power, just carry it down there. So you're saying that once it's a negative up, if it was a positive, was it a negative?
Oh, so
if it is
sir,
positive, I'll leave
if
it
I
alone.
did positive, it just cancel it because this would have done.
If it was positive, I'll leave it in the numerator. No, hold up.
I saw it go.
No,
so I can't see that, just leave it.
I just leave it, yeah. So I wouldn't necessarily cancel it because it can't be cancelled because in the denominator I don't have 5x squared raised to the half power. You see what I'm saying? So I can't cancel. What I'm saying to you, if it is a right, I would reduce it, right. So what I'm saying to you, the aim is once you have a negative power, you're going to reciprocate it so that it becomes positive. And when you reciprocate it now, then you see what is happening. Now I'm faced with two things. Unique says, sir, this now becomes 5x to the third power. That's what it said, Unique, right?
5x squared.
Talk to me, Unique. I don't want to misrepresent you. 100%.
No, yes, that's what I asked.
Okay, right. And I'm happy that Unique asked that question. And I'm gonna give you guys an opportunity, and this is what I'm saying, students will learn from each other, you know. And I like when questions are asked. Look and tell me whether or not you agree with Unique. Unique says, sir, based on what it is that you said earlier, when you have a base raised to a power, which in turn is raised to another power, you multiply the powers. So Unique is saying, sir, I look at that and I say that 2 times 3 halves is 3. So me, I said the answer is 5 raised to the x cubed. Do you agree with Yannick or do you disagree with Yannick? Let me hear it. When me I said, Yannick look on the one yasso, and she said that one yasso could be 5x to the third power. Me I ask you, if you agree, said this I go work out to be 5x to the third power. Yes or no? If yes, why? And if no, why?
When I see how we reach this up. Sir, when I already have 5x squared to the 3/2.
I come in honey bun trees.
Let's see how would I reach 5x
You're talking
squared to the
about
3.
that, sir, with the half and the 2
Very
power.
good, very good, very good, very good.
Sir, you know, at first I was looking at it that way.
All right, but me, I want to, forgive me. I'm actually looking for some other notes to put a notation there. And this is the beauty about online. You know, I was talking about you guys today with, well, I wasn't talking, I was boasting about you guys with another member of staff. And I was saying that, I'm supposed to go in. And no, let me just say something here. No, and that's the problem, you know, is when me boast by my students, wanna feel me and wanna see. Because when me boast, you know, me talk with confidence, you know. But no,
Sir,
I was
them things are over our life.
You know, in Jesus' name, I have to speak positive things.
We're not going to fail it, sir. We're
Oh,
going to make you wonder, oh, you don't talk so low, you should have talked higher.
Yeah, man. So, you know, one of the things I was saying is that, hold on, let me just, let me just make a notation here. Is
Ow.
Yeah, one of the things that I like about the class is that you guys are thinking. Whether or not it's right or wrong, you know, you're thinking. Now, watch me. So this is what I was suggesting to you. Note a to the m raised to the nth power is equal to a to the mn. All right? And forgive me for me going back and forth with the stuff because I have to try and get you guys to understand exactly what is happening. So as I went and copied this into the document, a to the m raised to the nth power is equal to a to the mn. When I'm multiplying, when I have a base raised to a power, which in turn is raised to another power, I'm multiplying both powers. So m is going to be multiplied by n. So I'm going to have mn. So this is going to be a to the mn. This is this. This is this. Please note that we're not trouble the power in the bracket. All right? I want you to remember this. We're not trouble the power in the bracket. And I want to remember this one. So this is patois, and this is English. Patois, and this is English. A to the m raised to the nth power is equal to a to the mn. Watch me. Watch me now. Remember, Lord? All right. So my question to you now is, am I allowed to say convert 5x squared to the 3/2 as is being suggested to 5x to the third power? Yes or no? If yes,
sir.
Yes, okay, I'm hearing yes. So Sash is saying yes. Anybody saying yes with Sash? I need to hear from you. Andrew, what are you saying since you're not talking? Andrew, what are you saying? You need already give me an answer.
Sir.
You're saying yes.
Sir.
Okay.
I would say the same thing.
Abby, what do you say, Abiana?
Yes, sir.
Charlie, what do you say, hon?
Yes, sir.
Sir, hold on, I'm gonna process this.
Yeah, one process it. Chetty, what do you say? David, you next. What do you say?
Sir,
yes, sir.
Okay, all right. Jermaine, what do you say? Krishna, what you say?
Yes, sir. Good.
Okay. Next one, what you say?
Yes, sir.
Nikbu, what you say?
I see it now, sir.
Okay.
I'm a pass.
You pass. Okay. No, you have to choose something. You can't pass. Crazy. You have to choose something. Ramesh, what you say?
Yes, sir.
Okay. Ryan, what you say?
Don't know my style right now, boss. Good.
You're good. All right. Shani, what you say? Miss Smith, please, I'm talking to you. Shana Lee, what you say?
I'm a thing this is Shani. Yes, sir.
Oh, yeah. Okay, cool. Shana Lee, what you say?
I'm still away to see my test grade.
Come off of my phone. Come off of my phone. Yeah, talk to you about something. Say you've gone back to the past. You need to forgive and move on. All right, let's go. No, Chetty. I'm not Chetty. Karika, you think you're smart?
What
Give me an
can you
answer.
do? Sir, my
You know,
answer you a long time.
Oh, I'm wait there.
I see it now, sir.
Mm-hmm.
Mm-hmm.
Can I tell that secret?
Yeah.
All on the wrong. All up on the wrong.
Wrong or strong, nothing wrong with that.
And nothing wrong with it, you know. As long as it's wrong and strong, nothing wrong. And I went to the banner wrong. And that's why I'm taking.
No, sir.
No,
Karika.
No,
hold on, let me guess what you're about to say.
Karika. The train leave you. The train leave you. You see when you got foreign.
You're funny, you know, you make me
and
laugh.
them shut the plane door. Them now open the plane door for you. So you can do it on your own. No,
sir, but let me just see what you're trying to say.
We're not enough for you.
Because,
no bad mind.
Sir, if you do that, if the sum outside, it will multiply everything right in the bracket, no. So then it would actually be oh, sir, I can't see.
No, I don't want to see.
What this again? 3/2. So that'll be 5 to the 3/2 and x times x to the square times 3/2. What is x squared to the 3/2, people?
X cube.
Me didn't know you know say that me I say. Sir, I just delayed. Sometimes slow. Stay with me.
Okay, sir. So the answer to my question is no. Thank you.
But before you go to the question, sweetie, before you go to the question, honey punches. This is a teachable moment, and I want to get the buy-in from the students now before I move on to the other part of the thing. I don't want to just slide over this. So give me half a second, Yon. Everybody agrees. Why is it that based on the suggestion that we got before that 5x cubed would not be the correct answer? Because these 3/2, Karika just peeped into my microphone and saw what I was writing, and then just was a secret. So she said, no, she just peeped into my microphone and see what was happening, and then decide that she was going to say. But remember now, whatever is raised to the outside of the parentheses, whatever is raised to the outside of the parentheses is going to be
affected by
every single thing in the parentheses. It is going to affect every single thing. Now, you see this piece here? This is the difference between 98% and 100%. You have to, it's a difference between 90% and 100%. So you have to be very careful. Just remember all the time, whatsoever is on the outside of the parentheses, right here, so is governing every Jackman inside the parentheses, not only piece, but every Jackman. So this can't be 5x cubed. It's 5 to the 3/2 times x cubed. All right. Yon, go through with the other part of the question, no, honey.
No, man, that was the question. I'd asked a question, but we'll go up on the icon and come back before we get the answer.
Yeah, man.
So I say, okay, so no is the answer to the question.
Oh yeah. But you understand, we have to go up on the hike first, though.
Yes, sir.
Yeah, man,
everybody did think the wrong thing too.
I'm me to tell you, man. Everybody
you know, I should have stick to my answer.
Everybody thinks that it was an easy road, and when them reach up at top and say, no, it's not an easy road, but very good though. I'm happy that we all see that. Lexon, you see, Papa?
Yes, sir.
All right, very nice. Now, there's only one more thing to write, you know, and let me go back and show you something. 5x to the cube. Should I put the 5x to the cube in a different color here, so that when you're listening to the recording, you can hear that I put the 5x to the cube in a different color, because I'm trying to bring across a point. Okay. Bringing across a point. So here one, the 5x to the cube is in a different color because I'm bringing across a point. Now, oh Lord, how do I do this? All right, so I'm going to be, all right, so this line is my conversion line. So 5x to the cube, you know what? Please note that the denominator, the denominator is now reduced to. I'm doing this so that Kelvita can see it, and when you're reviewing the stuff, you can also see that. So please note that the denominator is now reduced to that. So this is what we're working with. Can I agree? So that one we are working now, this?
Yes, sir, I agree.
All right. So look at what I'm doing. All right. So I'm reducing this. So this is our the reduction line. No. That is going to be equal to.
The question you know user friendly at
Oh goodness. Jeez.
Sir, I have a question.
Yes, Honey Bunches, go ahead.
I don't know if this makes sense, but why you couldn't reduce and say 9x over 5x squared to the half?
9x times 5x squared. What?
9x over 5x squared to the half.
I actually could.
Okay.
But it must be out.
No.
And then you have wait there, sir.
Uh-huh.
So are you trying to say the answer where you get after that wouldn't complete?
No man. I could. And you're correct, Karika, you're correct. But I am going on a trajectory because I saw something and I want to show you. No, let me tell you the trajectory that I'm going on. This journey up this mountain. You see this piece here, so? You remember I did highlight this piece at some point in time?
Yes, sir.
Yeah, because I saw something coming out here, so I want to show you something here, so. So yes, Karika, you are correct in saying, and I like when you turn up a class, it's a Karika. Jeez,
oh boy.
Yeah, man, trust me.
What a call out.
Yeah. I love it. All right. So Karika said, but sir, hold on. This 5x squared and this 5x squared have something in common. So I never just can't see it out here. So yes, I agree with you. But I want to show you something here. So please note that the denominator is reduced to this. So yeah, this part is still correct. But I want to show you something right here. So you see this 5x squared with raised to the 3/2. I can rearrange it as a square root of 5x squared to the 3rd. Can you see that?
Yes, sir. The denominator become the number for the root.
Very good. Excellent. So that's the point I'm trying to. This is a point I was trying to make. But right. But let me just put this in. Let me put this as a oh Lord, how do I represent this now? Let me put this, sorry, let me put this as a strike through. Let me put that, oh no, that strike through looks ugly. But let me put that as a strike through. I did that because I wanted to show you. I wanted to show you, as I was saying to you before we went to that line, I wanted to show you how it is that this piece comes up, because I know somebody can say, but sir, when it started the question, all I see in work is just this. And I never see you come in an example with this piece. All right. So that's exactly what I was trying to show you. That this piece, but if I put a strike through, you may think it's wrong. So I shouldn't put a strike through. So let me undo the strike through. Right. So the point I was making though is that this 5x to the 5x squared to the 3/2 could be written as this by a conversion, because the denominator tells me what kind of square root I have. What symbol I have here, a square root or a cube root, and the 3 in the numerator is going to be the power overall. But coming back to this, copy, coming back to that. You may not get a question like this in the exam, and I hope you don't get a question like this, but I'm stretching you guys so it is that you know what is really happening. All right?
It's
so coming
like 20 marks, sir.
Not quite. So coming like this. So remember, when we are dividing, let me see if I can. When we're dividing and the bases are the same, we subtract our powers. Remember, when we're dividing and the bases are the same, we subtract our powers. When we're dividing, copy, and the bases are the same, we subtract our powers. And the question looked long enough because, what do you see it, LL?
You carry around the world.
No, it's not a matter of carrying on the world, and I'm really explaining what is happening. So when I finish this, you know, yeah, man, I know, I fully get what is happening. So look at what is happening here. This is a to the m over a to the n is going to be equal to a to the m minus n. All right. So that's the recall I want to think about for just a moment. For just a moment.
So when I say, is sir the question not done yet?
You need leave me alone.
So these are most like around 20 marks for true.
I do set more 3 marks I give for that question here.
You know,
no, sir. It would have wicked for do that.
No, wicked. Cheese and peas. No.
It has to be at least 10.
So sir, it would have been, so sir, it would be 9x over 5x.
No, it would be 9x, and then I'm saying it's going to be 5x squared raised to this one minus 3/2.
Eh?
Watch me. And that's why I'm doing it, you know. I am doing this because I don't know what CCCJ will send, and I don't want nobody to say, boy, sir doesn't give me the easy one in a class. Watch what I'm saying to you. Recall, a to the m over a to the n is equal to a to the m minus n. So I'm saying to you, this is 5x to the 5x to the first power.
I see it now.
Yeah, man, 5x to the first power. So it's going to be the numerator power minus the denominator power. So it's going to be 5x squared, 1 minus 3/2. So it's 1 minus 3/2. So that piece, copy, is now reduced to, feel like me I teach big school maths. Very nice. 1 minus 3/2 is going to work out to be what? Tell me what is 1 minus 3/2? Excellent. Very good, Charlie.
And bring it back to a positive half.
Oh, I love it. Thank you, Sashibo. Love it. So you see what is happening? I'm vacillating between terms and between things. I'm moving from one something to the next. And sir, I saw the something you mix up.
The answer.
No, Kerika, do not ask it. Kerika, don't ask it.
I can't believe
no,
this.
exactly.
Sir, no wonder it gives so much trouble.
Leave me alone.
And then you go put it back to the square root.
Very good here, pumpkin.
Sir, you do this on purpose. You did feel you just get up and choose violence when you write this. Sir, are you pleased?
Oh Lord.
Are you pleased with yourself?
I'm overjoyed.
PhD.
I am overjoyed.
Yeah. No. PhD. And NASA me go work with me done that course. Me go apply to NASA.
I am overjoyed. Whoa,
no.
Yes.
So tell me, sir. Tell me something, sir. Because me, I gonna need you for show me everything where you give me marks.
Yannick, leave me alone.
Because guess what, sir? We could have cancelled out.
Hey, you see that too now, sir? You can do this two different way now, because
Absolutely.
me just cross out and so you tell me say me that miss out them marks, yeah.
And I'm just saying to you, you see, I am doing the question, because I want to show you what is actually happening. And as I said before, as I said, when you're talking about this, the question already called 2-3 pages,
Yeah.
The question already called 2-3 pages, and we're doing the highest math course, one of the highest mathematical courses in the college. So don't think that it's going to be a walkover, Let me just pause and say that again, somebody said a while ago, and I chose to ignore it, that I bet it's already about 3 marks for it. No, you see, when you do a little factorization question in a foundation concept one, you may see 5 marks for it. And a question like this, you may see 8 marks. And it's about, sir, 8 marks is somewhat something. A big school mathematics. Big school mathematics. Yeah, man. So we went over the mountain and the sea. Yeah, man. So we went all over the place and come back down. And then now, look at what is happening. You see how the question did look? Low answer, but the question almost looks similar to the answer. What answer?
The square.
9x squared over
5x. 1x cause this. One little x,
No. Yes. So you're right, Kirika. One decade x cause that something. Yeah. Now let me just be troublesome, because somebody may say, then sir, Lexon may come and say, then sir, if I see a question come like this, like 5x to the second power over all of this, sir, I could just write 5x and just all of the denominators as the answer. No, you have to go work with something, right? You have to work with something. All right. So this was a little bit of workout for you. I know. I agree, and I'm praying that the question that you'll get for your exam won't be as troublesome as this one was.
Look here, sir.
Sir, yes, one question.
I'll come in. Let me hear the look here, sir, first, Sash.
Yes. All right, sir. So, maybe I'll take the question, but maybe get it wrong from the beginning, because it was the quotient rule, but must work up for the example, the product rule. Notice.
Yeah, that's how I started it too.
I want to do it as well. Except the only difference was that I did for the factorizing part, I put 3x instead of 9x. I realized I was beginning to wonder if it was the same answer I was going to get. Interesting though.
Sir, yeah. What if we did try to do it with the product rule though? Like we just flip the fraction and arrive at the same answer.
Almost the same.
All right. Now it is that you guys are thinking like Calculus 1 students. So what we're saying to Mikirika is, what if we had said 9x squared times 5x squared to the negative a half and use the product rule? Yes, honey bunches. Would have gotten the same answer.
And would I reach there quicker?
That's the last part of the end.
Sir, would you have needed to put the 5x
in a denominator
in order to do that?
No. I'm going to show you what it is. I'm actually typing it.
9x squared.
Actually get the
5x
9x and the 5x 5x squared inside, but then we put something by the top from my one.
That me that try figure out how to write it.
Oh, yes.
That me that try figure out how to write it properly.
Yeah.
Right. So Krishna, this is what you're saying, right, Papa?
Yes, sir.
Excellent. So and I'm going to say it again. This is why it is important for us to have conversations in a class. Because yes, you are correct, Krishna. Karika, yes, you're correct. Dani, yes, you're right. If I'd seen this here, I chose to use the quotient rule here. And Karika said, then sir, I'm going to use the product rule by just flipping this and character negative. When I get to the answer faster, chances are the first time the differentiation of the second plus the second times the first. You're going to do this for homework for me and tell me if you get the same answer. What do you mean? What do you mean? What's your, you think you're here for pretty looks alone?
The last part. Basically, the most set already.
Sir, we know we are going to reach the same answer.
Leave me alone. Leave me alone. Yeah, Karika, make sure. Ask KM next class.
So anybody can name KM?
Is that right? You mean know who's one KM in my class? Yeah, man. I want you to try that. And the truth of the matter is, it's when you do it and you do the same and you feel comfortable and you get the same answer. You're gonna say, but sir, I can't do this stuff. You know what? Let me just say something here. I did say, oh Lord, I was being a Christian. I was saying something that somebody may use a different method to get something. Remember I was saying that earlier?
Yes, sir. With the naming.
Right. Very good. Up here, so yeah, very good. You'd end up with the same answer. I can't find it, but you'd end up with the same answer. So you need to decide, so should we use the quotient rule because you're bad on the quotient rule. Karika saying, sure, yeah, the denominator times the differentiation of the numerator. You're going to forget to square the denominator all squares here. I'm going to end up with something like the 1 here and got things like x squared. I am going to go ahead and use the product rule. The choice is yours. If at this point in time, you decide to convert this to here and use the product rule, we can't mark it wrong. It shows you your flexibility in differentiating.
Real, sir? You don't mark it right?
Absolutely. That's the point I'm making. Why think I put it on the paper and say, do no one ask Karika come next class to show our answer? Yes, sir. Yes, ma'am.
Sir, one question, please.
Yes, sir.
Sir,
no, man. All right, your background have a lot of. Hey, tell them say to take out them calculus book and stop making noise in the class. Go on, your Nico.
Sir, all who know me know that's the impossibility of that one.
This one here?
No, sir. My question, sir, is back to way of the 9x bracket 5 bracket the 5 x squared, sir, not there, sir. Sir, down more.
Here, sir?
No, sir, down to the bottom of the question. Before you're going to do a n times this, yes, sir, right here. Sir, if when I got this right here,
right here, yes?
Yes, sir. When I got that right there, I cancel. If I do just cancel it instead of move to the part right there, somebody them just cancel it and say, this into this goes, the x into that goes one time, and then the x into this will leave. I'm gonna get the R. I mean, look. That wrong?
All right, mute. Let me respond. All right, thank you, honey bunches. And I can understand that sometimes you can't control the disturbance around us. So I'm fine by that. So don't feel no way when I ask you to mute. All right. So if I heard you correctly, Anika, you said we could cancel the x's. We can't cancel the x inside here. You know why? Krishna said earlier in the class that when the power is raised to 1, we can get inside of the parentheses. But the power for this denominator here is not raised to 1, so we cannot get inside the parentheses. This is a barrier. This 3/2 is a barrier to get inside here. This one says we can get inside here, but this 3/2 is a barrier, so we can't do no cancellation of inside here, so with inside right here, so.
Sorry, she said not the x.
Sir, I think what she's asking is if she can say leave it to 9x over 5x squared to the, what you call that now? 3/2 minus 1 hour. 1/2 to the half. Remember 1/2 to the 1. Whatever that is, sir, because we can't do subtraction.
Sir, sir, when you're subtract, when you're dividing, you can just divide it by it without doing what you do on the bottom.
1 minus.
If I may divide the entire 5x squared into this down here, you'll get, because so if I may divide it, you have to keep the sign and then you have to get a half because the 1 minus the The 3, 2 minus the 1, I got here
negative half.
No, it now give negative half.
Yeah, okay, that's what she's saying. Okay, all right. And that's the same thing I did on Onika. That's the exact thing we did on Onika. So what Onika is saying is that if you just cancel out this with this down here, so it will give you 9x over 5x squared to the 1/2. That's what you say, right, Onika?
Yes, sir. Would that be okay without modeling down here? So we are
and Onika, that's exactly what it is that I did right here. So, but I was showing you the steps to get to this point. So what you're asking me about this cancellation right here, so is exactly what I did. These are the steps, Onika, in order to get to this point here, dearest. So you are correct. These are the steps. What are the steps, sir? I'm showing you how we're doing the cancellation from here. So what you're asking me, honey bunches, is exactly what it is that I did. So this 5x squared, I'm canceling into this. But how do I cancel when I have a base raised to a power? It is going to be the numerator power minus the denominator power. See here, the numerator power is 1 minus the denominator power. So I'm going to get this to the negative 1/2. And because it's to the negative 1/2, I have to flip it back to the denominator. So this is how you end up with your answer, Nika. So I'm showing the class how we'll end up, because this is what you got based on what you just asked. True or false?
True, sir.
So it's the same thing that you're doing.
Sir, if I skip everything, still I get the number.
Okay, fair enough. All right. So you're asking me if you skip these 2 lines here, because remember, you know, right? I would give them up because I would know that you would have done this stuff in order to arrive at that. But remember, what I want you to do, you know, remember, my notes here that I'm creating are notes that somebody looking at this step down to this step will wonder how I move from there to there. Talk truth, class.
Yes, sir.
Yeah, man. Yeah, man. Somebody can say, sir, how you move from there? So, sir, I'm not seeing it. So that's why, Onika, I'm showing you there. So when you grow mathematically now, and you don't have to, it's all of them recall here, and please note and remember that you don't need to do this when you're doing the question. I am doing this for a teaching purpose. For a teachable moment, I'm doing this so that I'm writing all the steps. All of them note here. These are notes that these are my explanations, so that when you're doing the question on your own or revising, you understand why it is that I did what it is that I did. So you are correct, honey bunches. You can move from here so to here so. But for the purpose of notes creation, I'm showing you exactly how it is that I would have gotten my answer right here. That's what I'm doing here. So yes, you're correct. All right, I'm going to end here. I know we have yet another question. Trouble.
Touch that, sir. Trouble.
I'm not going to touch it. But the only thing I'm going to do is just to rearrange, and then you can see what it is that I'm talking about right here. I'm just rearranging, so just be around with me. But if you ask me though, yes, honey.
About the previous question, just a quick question. Where you have the if I did not flip it the first time to say 9x times 5x squared to the half, to the negative 1/2. If I left it in the denominator, how would I end up make it positive? Me just try visualize that.
I'll come into you. All right. Which part? Right here, so?
Above that, right there. If I had left all of that as a fraction.
As a fraction?
Because remember, the question is in a fraction state.
So you're asking if you leave the answer, the question like this as a final answer? That's what you're asking?
No, sir. Okay, scroll up a little bit, sir. We have 9x. That's a fraction, right? So I'm saying if I had left it as 9x over 5x squared to the negative a half.
No, it will be 5x squared to the positive a half, which is this. Mm-hmm.
When
So
the
this
half go to the denominator, it will
become positive, right? So this is what it will be, 9x over 5x to the positive a half. And then, of course, there's one other step that I can write. This positive a half, this is saying that it's a square root of 5x squared. Come on, trust me on that. Do me a favor. I want you to go to the question again. And just look at that. I'm going to use 2 minutes to just show you something here, and then you can finish it off for me.
Sure.
The truth of the matter is, you notice I did say that I was going to start integration. I think we're moving at a steady pace. You guys are understanding. I'm not here to show off that I can do integration. My aim is that you understand the things that I'm teaching you, which is I'm going so slowly and so in depth with what is happening. So the questions that are being asked just now are very valid. Sir, do I have to go? I could do the question in the 5 lines. You are using 10 lines. Yeah, I'm using 10 lines because I'm doing my explanation, and I want when you're going over on your own, we can follow exactly what is happening. All right, watch me.
Sir,
yes, honey.
With the with that rearrangement, why wouldn't it be x raised to the 4/3?
Very good. I don't finish yet, so that's what I'm saying. So all I'm doing here is just excellent. Is just converting this as x to the 4th, and I'm showing you that it is raised to the 1/3. So it's the same point that I'm just making you make. That I'm doing it in stages because I don't want when you're going through and stuff and you're confused. I want when you're doing your self-paced stuff, you can see what is happening. So yes, you are correct. I can have this as,
but the 3x squared will remain the same because the squared is not for the 3.
Very good. You see, come back to the one that we were talking about earlier.
Yes, sir.
Come on. So that would be my next step.
Almost Mr. 3, no, sir.
So you see what is happening? So Yannick, just remember now what Sir said earlier, that this x squared, yes, is being affected by this 1/2. So is a 3. So I am not even going to do any conversion. You're going to make it stay right here. So now this becomes a product. I don't like that parenthesis. That's so big and odious. So let me just remove it. So this now becomes the product. This times this, right? And you're going to work it. You know, you have a power rule right here. I'm just going to work it out. You're good to go. So I want to finish out that for homework for me. And you're good to go. But let me just sum up for tonight's class. It is literally minutes to 10. And you guys are still energized for class. I'm truly appreciative of this.
Who said that?
When I ask you, may hear it in the voice. Someone is gonna sleep now, but there are some of you that are still with me, and the brain is still clicking. Very good.
Sir, you read the chat.
Rockstone. Let me hear what they must about the teacher now. Okay, laugh. Sherika said, Kirika can laugh, see? Entire thing. Not the F, sir.
True still. I'm not lying.
Man, the chat good man.
No, sir, I think you need to scroll to let me tell you what time.
It's only German alone can German and women and Ryan.
Sir, scroll to 9:23.
9:23.
So log that, sir.
Kirika, leave me alone. All right, sure.
What, 57 minutes ago? Mercy.
Right. But guess what? You shall be fine. Oh, geez, I'm looking at trouble, my friend, and him say great teacher. That's what my friend about, you know, when time come for me, just
he was talking about Miss Maureen.
Oh, geez, shame. Thank you, Sasha. So I will just take my shame. You know, this is like me running on the bus. Sir,
bus driver
listen to them,
drives
sir.
Okay,
They
no
will
problem,
charge you,
no
sir.
problem.
Jeremy, Sasha just
Sir,
cracked my
you say I will
style.
charge you already. So listen to Sasha.
It's all right. Guess what, no, Jeremy?
God.
This is me running on the bus, and the bus drive gone. I'm still running because they
No,
don't
we stop, man. We stop. We're playing.
All right.
Jeremy love me.
Remember, see, I'm KC fan tune, so you put
That's
me
why I'm
in.
not gonna say that. I'm just about to say. That's why I love me.
Oh, Jesus, I tell
Yes,
you.
and then
Yeah, man, the Casey funny. Yeah, man, trust me. No,
Wrong
rump it on
side
our
of-
purple.
of
Rump it
my
on our purple. All right, guys. Always enjoy my class, whether or not I'm not in a good mood. You know, it always works out for good. Please, just keep the momentum going. Continue working. I will work on this registration something for you. I promise you. And then I will let you know so I can release those papers to you. That's why I have not released any other paper. But fret not, you'll get it. Bexton, big up yourself.
no in Excel, sir. Them not go.
No man, it's all right.
Sir,
I'll
wait,
work
sir,
on it.
before you run, sir, one question for you.
All right, you don't know how to sleep.
No,
class done, man, Ryan.
Sir.
Go ahead, please.
Sir, if everybody can go on them. But sir, I have a question, sir. Sir, where you get the 4/3?
The 4/3? Oh, A to the M. When I have a power, a base, raised to a power, which in turn is raised to another power, I'm going to multiply both powers.
They multiply, not add. Okay, sir.
No, they multiply. Hold on, Nikaboo. Hold on, Nikaboo. You need to see it before we go because you have homework to the teacher, sir. Note, this to this, raised to another power, we're going to multiply both powers. All right, so this is 2 minutes past Ryan's bedtime. So we're going to say good night to here. Gentle Jesus, meek and mild. Have a wonderful rest of the night. Bless upon a heart here.
Good
night,
sir.
Easy.
Easy.
You better.
All right, sir.